Hello, everyone, and welcome to our first online meeting for this semester. We would like to introduce Ingo Plag, presenting Morpho-phonetics, the role of the acoustic signal in morphology. So, Professor Botinis, back to you to present our guest.
Okay, thank you, Athena. Welcome, everybody. Today, we have Ingo Plag from Düsseldorf. Well, during the last year, I've come out learning a new language. I found out that pronunciation and morphology, or lexicon, are the most important aspects in language. Because going back decades, when I was in Italy, I would say in a restaurant, pollo per favore. Pollo is chicken, and per favore. Or wine, or this Ramazzotti, Amaro, Amaro per favore. Pronunciation and lexicon, despite all other theories. So I thought, morphology. Who is the guy to do the job? I look around, and then I came to Ingo. A lot of work about morphology. I mean, a lot of work. And that is what I had in mind. But Ingo comes with a better suggestion to combine phonetics and specifically acoustics, the acoustic signal. I mean to say, many years now, the usual term is morpho-phonetics or morpho-phonology, not morpho-phonetics. And of course, not at all morpho-acoustics. Well, it's a lot of questions. What is the role of phonetics in morphology? How do we decode morphology? Do we go directly from phonetics or acoustic or production to morphology? Having in some time of store the acoustic signal, or do we go via phonemics, syllable structure, and so forth? It's a lot of interesting things to talk about in combining phonetics and acoustics with morphology. So today we will have the pleasure to attend this lecture and hear Ingo what he has to say in those crucial aspects of language structure and communication. Please, Ingo, go ahead.
Yeah, thanks very much. And thank you also for having me here. It's a great pleasure to talk about the stuff that I've been working on over the past couple of years. Actually, I even spotted one of my co-authors here, Simon Stein. I hope he can correct me if I say anything stupid. So I will now start screen sharing. And I hope you see now the first slide, Morpho-phonetics, the role of the acoustic signal in morphology. The way I would like to do this is that you can interrupt me anytime if you have a question of understanding. I don't want to lose anyone along the way. If you have any question on or comments on the significance of all this, or have questions at some other level apart from understanding, then I would ask you to postpone them until after my talk, because we will have plenty of time afterwards to discuss everything. Okay, so if you have a question of understanding, if I'm losing you, just turn on your microphone and shout your question. Thanks. So Morpho-phonetics, it was already mentioned that morpho-phonetics is something of an unusual term, and actually I only started using it a couple of years ago when we first discovered some phenomena in this area. And I would like to present work here with quite a few co-authors that we have done over the past years to explore these effects in morpho-phonetics. So what are we talking about? Where do we come from? The way I was brought up is the following. There was no morpho-phonetics. There was only morpho-phonology or morpho-phonemics, as it was called. And there are three tenets of this morpho-phonology business. The first is that morpho-phonological alternations are held to be categorical, but may have lexical exceptions. And the second one is that the formal level of representation of morphemes is phonological in nature. And post-lexical phonology and phonetics have no access to lexical information. These are three basic assumptions that I was brought up with. So everything has to play in this domain. However, there are problems with this, and I want to talk about problems concerning number 2 and number 3. I could also talk about number 1, but not today. So we will focus on the formal level of representation and post-lexical phonology and phonetics. So first, the formal level of representation of morphemes is phonological in nature. What does that mean? Why is that important? Take a look at some English suffixes. The way their morpho-phonological alternations are described is illustrated here. You have maybe two allomorphs or two ways of expressing a certain suffix, in this case, ik or is, and then you try to understand in which context, which kind of pronunciation is prevalent. So you might want to say there is this ik that is pronounced is in certain environments. And depending on your preference, you sometimes see this expressed in slashes, but I never understood why you would do it in slashes or why you would do it in brackets indicating phonemic versus phonetic representations. I never understood that difference in this context, and it's never talked about in textbooks actually. So what is important is that there is no reference to subphonemic detail in these rules. Subphonemic detail is just irrelevant, so we think. The same for the plural, the third singular, the genitive s, which in my own work I have described like this. Again, there's an alternation between z, s, and is, and then you describe the environments, again using either slashes or these brackets to indicate the different levels. But again, no reference to subphonemic detail, and therefore there's nothing to talk about concerning morpho-phonetics. The same then would basically hold for a model like the one you see here, which is an updated version of Kiparksky's lexical phonology morphology model, here in the guise of the recent version called stratal optimality theory. But the details are not important. What is important is that most people think, or used to think, that once we have created our words in the lexicon and we've done our word level phonology, for example, stress shift for itty words, then we pass this on to the syntax, and we are there now in the post-lexical phonology. We leave the lexicon, and then what can happen is only phrase level phonology, like sandhi phenomena between words or intonation, or what you have in syntax. But everything in the lexicon is done with, and we don't even know that a word that we pronounce in the syntax is morphologically complex when it comes to its pronunciation. It's only the inflection is relevant maybe for agreement for the syntax. But once we've built these words and they leave the lexicon, we don't no longer know what their morphological makeup is. We've sent them to our articulators and then the thing is done. This is the theory. But there is also a psycholinguistic version of this linguistic theory, and that's the speech production model that has been very influential over the years, and that's Levelt's speech model. And as you can see with the reference Roelofs and Ferreira, 2019, not much has changed in the domain that I'm talking about here. So how does speech production work in this psycholinguistic model? We start speaking by having an idea, a concept, and then things move on down to pronunciation. And here, this is the level of concept, and you can see this is the concept. I want to talk about caps. And in order to do so, I then need to look up in my mental lexicon the lemma. This is the place where this idea finds an entry which has a particular meaning and has then a particular linguistic expression like a noun, and the properties of these nouns that are grammatically relevant are also listed in addition to the meaning side of matters. Once I have found the right lemma, I look up the phonological representation of the things that I have found. So in this case, the representations you see here for plural and for cap. And then I need to apply my morpho-phonological rules so that out comes the S, for example, for the plural instead of the Z or the is. And then you send this on to a so-called syllabary where you have the syllables listed. And once you have chosen the right syllable, you send this on to the articulator. And the articulator is the module that then tells our articulators what to do, how to pronounce the thing. And out comes then the acoustic signal. And the crucial point in the context of this talk is that no morphological information is available post-lexically. That is, after you've left the lexicon and you are in the syllabary, this syllabary has no idea about morphology. And this means that we predict that we never find any residues of morphological structure in the speech signal itself. However, there are reasons to worry. It's probably not correct to think in this way. For instance, it was found that free and bound variants of a base may differ acoustically. So the book in books is not the same as the book in book. Maybe you heard the difference, haha. Duration of Dutch compound linking morphemes. So in Dutch compounds, you have an un or an s sometimes in between the two elements that make up the compound. And which one, how you pronounce these, how long you pronounce them, depends on how probable they are. You find both of them, and if they are more probable, they are longer in their duration. Clara Cohen found that vowel frontness of Russian verbal suffixes depends on the paradigmatic probability of that particular vowel. So if it's more probable, it's pronounced differently than if it's not so probable. She also found that the duration of third singular S in English depends on its syntagmatic probability. The duration of English final S depends also on its morphological status, as we found out in many studies of different varieties of English. And there are many, many other facts that have been found out about the phonetic variation that correlates with morphological variation. And this is a challenge for existing theories of morphophonology, of the mental lexicon, and of speech production in general. And this raises then a couple of questions. The first type of question is, what morphophonetic effects are observable? Which morphological structures show such effects and which ones don't? How do these effects play out? So for instance, you've seen here that vowel frontness, so that's the formant structures, but also duration seems to be another way of how these effects play out, but which effect would play out in which way. And of course, the perhaps most interesting question, how can we explain these effects? What model of speech production can derive this instead of being surprised by it? So today I want to talk about some recent findings in our group, and this group is the research unit 2373, spoken morphology, with a couple of projects that are all interested in these questions of morpho-phonology and morpho-phonetics, funded by the German Science Foundation. So number one, which morphological structures show which morpho-phonetic acoustic effects? I'll give you a short overview of the literature here. So if we look at the morphological structures known as stems, there have been findings concerning the duration of stems, so that free versus bound stems differ, stems with different affixes differ. There's aspiration of stem initial plosive after prefixes that reflects morphological differences of these prefixes. If we take a look at affixes, people have found that there are effects of morphological structure also with suffixes and prefixes. I mentioned that already, that for example, the suffix s in English can have different functions, and according to these functions, the duration differs. We also find effects in paradigms. That's the one that I mentioned with, for example, with Cooperman's study of the Dutch linking morphemes, but similar effects have also been found in paradigms with stems and suffixes, and I will say more about that later. Formants, the paradigm structure can influence the vowel formants, and also at boundaries, at morphological boundaries, people have found effects for compounds, for prefix boundaries, and for suffix boundaries, where something happens across the boundary, and if you have the same sequence, for example, of sounds without a boundary, then things play out differently. Similarly, in co-articulation, assimilation across morphological boundaries, there's research that reports nice effects of morphology. However, we should also point out that there have been also null results. Of course, these are not so often published, but if they are published, you can read about them. And for example, one interesting comparison is that between final S in English and final ED in English, where it seems to be consistently the case that ED doesn't show the differences in phonetics according to morphological function, but S does. Nobody knows why. Or people have Schlechtweg and Greve-Corbett, they found that the differences that people found with English plural S versus non-morphemic S cannot be replicated with pluralia tantum S's. So if you look at nouns that have a plural S and those nouns, a real plural S, and those nouns that have a pluralia tantum S, you don't see a difference between those two S's. That's apparently too subtle. And there are also results of co-articulation across morphemic boundaries where this is either variable or not existent at all. So that's also a puzzle. Where do we find it and where don't we, and why is that the case? Now, how do these effects play out and how can these effects be explained? I will present to you 3 studies with morphophonetic effects in paradigms. So where forms in a paradigm influence each other because they are in a paradigm. And I will, in terms of explanations, I will show you 3 studies that have applied discriminative learning as an explanation how morphology can leak into the articulation and therefore in the acoustics. And since this is supposed to be a tutorial and not a conference talk, I think that I would also like to point out that there is a methodological lesson to learn in this, at least in this domain, but I think it holds generally these days in linguistics. And that lesson is that it is really a good idea to combine different types of data and approaches if you want to learn more about a puzzling phenomenon. So in my case, I will draw on real speech by real people in real normal situations as they show up in speech corpora. And of course, experiments are still necessary to test certain effects for various reasons. I don't have to tell you that in the context of this society. And there's also computational modeling. I think linguistics must move beyond impressionistic theorizing, where people have many good ideas and write wonderful monographs, but the empirical test is often missing. Why? Because the computational models that would be necessary to test these ideas are simply not there. That's part of the history of our field because we haven't learned how to do it. But I think it's time that we team up with people who know how to do it and then learn from them how to do it and then see how far we can get with our theories and ideas. Okay, let's start with the paradigm cases. The first study I want to show you is on plurals versus monomorphemic words. And it's about paradigm uniformity or paradigm leveling. Now, what is this? The idea here is simply that forms in a paradigm may influence each other by becoming more similar to each other. And usually paradigm leveling refers to historical processes where paradigms become more uniform. And paradigm uniformity as a term is very popular in OT circles, where people try to explain the effects synchronically. And most of the talk in paradigm leveling or paradigm uniformity is at the phonological level. So take a look at this historical paradigm leveling process where stride, strode, stridden, a three-stage upload, has become, for most people, stride, strode, strode. So you see that the paradigm has been leveled. The two forms here, strode, have replaced the two different forms, strode, stridden, from an earlier stage. By the way, can you see my cursor?
Yes. Yes.
Okay, thank you. Thank you.
To some extent.
Okay. Another case here is a synchronic one. And you see here the words solid, humid, and if you add ify to them, there's a stress shift, solidify, although the base is solid. Same with humidify. Now, this is a bit unexpected because ify does not stress shift usually, but it consistently does so even in experiments with new words if the base word ends in id and has two syllables and stress on the first syllable. Now, how can we explain this curious exception of the generalization that ify does not stress shift? Well, I think what we see is that it's a paradigmatic effect in the paradigm of the morphological family of the base solid, because we also have solidity, humidity, and the curious fact is that all the words that you find in the lexicon that show this shift are words where the ity form was attested much earlier than the ify form. So this is a kind of paradigm uniformity effect that also happens with speakers these days. Okay, but what about the phonetic level? Is there also phonetic influence of words in a paradigm, and some people believe yes. And we look at a study by Scott Seifert and colleagues, and they looked at the influence of words like free. So if you take a look at the paradigm of free in English, it's pretty small if you come from a different language, but it's free, freeze, freed, freeing. And the whole point here is that the word form free has a longer stem duration than perhaps any word where there would be a consonant following, because you have this effect of lengthening before the end of the word. Now, from this, we can then assume if free affects other words, the idea in its paradigm, the idea would be, if you want to pronounce freeze, third person singular freeze, that then the articulatory gesture of the longer stem free will affect how you pronounce free in freeze. It will be longer also in freed and in freeing than it would be if compared to the word freeze as a monosyllabic homophone. So in other words, we can, due to the influence of free inside the paradigm, due to its articulatory plan, which is longer than usual, so to speak, it will influence the other words in the paradigm, but it will not influence the homophone freeze, which is homophonous to the third person singular form. So we expect the free in third person singular freeze to be longer than the free in the verb freeze, that is monomorphemic. This is at least what Seifert et al. Found. They found that the stems of S-suffixed words are longer than the corresponding string in homophonous monomorphemic words. That's called paradigm uniformity. And what we wanted to do is to replicate the phonetic paradigm uniformity effect with authentic speech, because they had done it in the lab with all sorts of problems. And we also wanted to investigate the effect of frequency and reduction, because we know that more frequent words are usually pronounced shorter. So we wanted to know how this would play out in this paradigm uniformity effect, because that was something that they controlled for in their experiment. So what we did, we used the Kiparksy corpus. This is New Zealand English, and it's a data set that has been used before by somebody else. So all the annotations were there and nicely done. And so that was a perfect corpus to start with. And we sampled from this corpus, in order to reduce the variation a little bit at least, only the monosyllabic words that ended in Z. We only sampled monomorphemic words and plural words, and we only sampled words that had a final Z that was preceded by a vowel. So that kept constant at least some of the possible variation. And we only took words where we had at least 3 tokens per type, which made us end with this rather small data set. But we are used to small data set actually, and are able to squeeze things out of these small data sets. Okay, and we tested 2 hypotheses. The first one was basically Seifert's. Stems of plural words are longer than corresponding parts of monomorphemic words. So that's the free freeze or the days example. That's what we called categorical paradigm uniformity, because the way it's formulated, it should be categorically the case. However, we also thought there should be a different effect observable in addition. The more frequent the bare stem is, the shorter the bare stem would be. That's the general reduction effect that we know from the literature. It's well established. But if that is so, and the bare stem influences the inflected word then we should expect that for these cases, the shorter the plural stem would become. So if you have a more frequent bare stem, then this bare stem should be short. Therefore, the articular gesture that also influences the inflected word should be also shorter, and therefore the plural stem should all be shorter, should also be shorter. That's the idea. And we call this the gradient paradigm uniformity effect, because it's gradient because it depends on the gradients of the frequency of the bare stem. Okay. How did we do the statistical modeling? The problem with corpus data is, of course, that they are more messy, less control. That means you need a rather sophisticated statistical modeling technique. In this case, we used multiple linear mixed effects regression. We also used random forests to address collinearity issues and also other measures to take care of collinearity. We had different variables of interests. So whether the word was suffixed or monomorphemic, then the word form frequency for some questions plays a role, the stem frequency and the relative frequency. And we had a number of control variables that we basically took from previous studies, from other people, from suggestions we got at conferences. I don't want to go into the details. It's a whole range of the usual suspects that influence phonetic implementation. Okay, what are the results for the categorical paradigm uniformity effect? I repeat the hypothesis: the stems of plural words are longer than corresponding parts of monomorphemic words. We indeed find a difference. You see here on the y-axis the duration of the stem, and you see the distribution in the violin plot, and you see the median here, and the mean. That's the dot, I believe. The dot is the mean. And there is a difference in the mean, but this is not significant. So in other words, we don't find the categorical paradigm uniformity effect. We find, however, all the effects that we would expect from our control variables. I don't want to go into the details because it's boring. It's what you expect. So the data are well behaved, but they don't do what Seifert et al. Would expect them to do in terms of the categorical paradigm uniformity effect. So we have to reject hypothesis 1. Now, for the gradient paradigm uniformity effect, I repeat the hypothesis again. The more frequent the bare stem, the shorter the bare stem should be. That's the general phonetic reduction effect. And due to paradigm uniformity, then the shorter the plural stem should be. Here you see the decisive effect. We increase the stem frequency. That's the frequency of the bare stem, of day, if you like. And on the y-axis, you see the duration of the stem when it is part of a plural. So that would be days. And you see that the higher the frequency of the stem, the higher, the smaller the duration of the plural stem. And we interpret this as an effect of gradient paradigm uniformity effect. This effect is significant in spite of the fact that we have rather few data points here. So the more frequent the bare stems, the shorter the plurals. We can summarize, therefore, that there is no robust effect of categorical paradigm uniformity in authentic speech. And however, we find a clear effect of the gradient paradigm uniformity in spite of the small data set. Okay. So the question is, how does this then go together? Why do we find this gradient thing, but not the categorical thing? Do words now influence each other, or don't they? Or under which circumstances? So which forms in a paradigm may influence which other forms, and how do they do this? And when do they do this? And is there a threshold, or what's going on? So as usual, more questions than answers. Let's move on to the next study that has looked at paradigmatic effects. And in this study, we looked at the phonetic realization of consonants at the internal boundary in English compounds. And here the research question was, what factors influence this duration? For example, in steam engine or tuna sandwich, does the morphological structure somehow influence the duration of these consonants? And there are, in fact, 3 hypotheses that would predict certain effects. So, for example, the informativity hypothesis would say higher informativity would lead to lengthening. Higher segmentability would also lead to lengthening. So if a morphologically complex structure can be more easily segmented into its parts, then this is expected to lead to more lengthening of these parts. And we have the paradigmatic support hypothesis, which says that the more paradigmatic support is there, the longer these items are pronounced. Now, the question is, of course, how do we measure informativity or segmentability? And I show you 3 things in more detail. So one is the transitional probability of segments at the boundary. So this is basically about informativity. The transitional probability tells you how likely it is to move from an N at the end of the first constituent to an N in the second constituent, or from an M to the E to the E in the second constituent, and so on. And as usual, if something is highly probable, it's not informative and therefore should be less long in its pronunciation. Constituent frequency is another measure of informativity. Of course, if a constituent is highly frequent, it is not very informative. So, for example, the compound, the so-and-so thing is highly frequent, and it's not very informative as a word. And there's another nice measure of both informativity, paradigmatic support, and also of segmentability, actually, and that's constituent families. And I will briefly explain to the non-specialists among you what a compound constituent family is. So there's the first constituent family, the N1 family, and this is all the compounds that have the same first constituent. So in the case of time machine, it's all the compounds that have time in the first position. And as you might already guess, the N2 family is then all the compounds that have machine in the second position. And there are many interesting things that can be predicted through these families. But I want to focus on conflicting predictions here because they are the most interesting ones. So the first conflicting prediction is the one where the segmentability account would say the greater the N1 family size, the longer the consonant duration should be. How does that work? If you have a great N1 family size, I go back quickly. So if N1 family size is very high, you have tons of compounds with the first element time, for instance. Then what does that mean? Then N1 is highly productive, and that means that then these compounds are easily decomposable. And that then would lead to longer consonant duration, according to people who believe in segmentability. There's the paradigmatic support hypothesis that would predict the exact opposite based on the same measurement. The greater the N1 family size, the paradigmatic support people would say, the more possible values you get for N2, the more spread activation or uncertainty you have, and therefore the consonant duration should be shorter because of this uncertainty. If you have tons of other possibilities, you don't know what's coming, and therefore pronunciation becomes shorter. Another conflict is between informativity and paradigmatic support. Informativity would have an effect where greater paradigmatic probability of the consonant would mean that this consonant is less informative and therefore would be shorter. However, the paradigmatic support hypothesis would predict the opposite. If there is a greater paradigmatic probability of a consonant following, then there's more support for this one, and this would then give us a longer consonant duration in line with Kuppermann's compound linking morphemes and the form and structures of Clara Cohn's experiment with Russian. So what did we do? We had an experiment with 3 consonants at the boundary, either with the same consonant or with the consonant followed by a vowel, as in steam engine, or the consonant being following a vowel, as in survey manager, nursery nurse, or tuna sandwich. We did this with carrier sentences. They talked about the line item again. And we did mixed effects regression with consonant duration as dependent variable. And we had a couple of variables of interest, all measures based on a big corpus. And I only want to talk about the 3 that I already mentioned. There are also others that we investigated, but they didn't have an effect. So spelling ratio, for example, is an indication of how entrenched the words are. Compound frequency, so that would be a segmentability measurement. Compound frequency would be an informativity measurement, and so on. I only want to focus on the 3 ones that turned out to be significant. We also added many noise variables, again, because there's so much variation that you want to control for, in spite of the fact that you did an experiment. So here's the result. There's one nice effect of the paradigmatic probability of the consonant, and that you see on the x-axis, and on the y-axis you see the duration of that consonant. And as you can see, the more probable the consonant, the longer it becomes. This is clear evidence for the paradigmatic support hypothesis and clear evidence against informativity. Now, if we take a look at log n1 family size, we see that for 2 environments, the CV and the VC, there is no effect, but there is an effect for the geminated consonants, which means that there is, and this is if this effect is in the direction of paradigmatic support, and we find no evidence for informativity or segmentability here. And finally, however, we find one measurement that is the log n2 lemma frequency, where we have a piece of evidence for an informativity effect, but all the other measures for informativity did not play a role in the consonant duration. So what do we conclude? We find that the paradigmatic enhancement hypothesis is well supported. There's no support for the segmentability hypothesis, and there is obviously a very restricted role of informativity, if at all. Okay, let's move on to the 3rd study of paradigmatic effects, and that's on Dutch variable plurals. So Dutch has 2 plurals, the S and the UN plural, and sometimes these are variable. So here you see an Egyptologist who talks about pyramids, as you can see below the picture. And what is really striking is that within one sentence, he uses 2 different plural forms, and you cannot say that this guy doesn't know what he's talking about. This is really exactly what he can talk about with a lot of knowledge, and still you could think he varies in plural. Now, if you take a broader look, you can find out, and many people have done this, that the choice is governed by probabilistic phonological rules, or by analogy or similarity with other words. And sometimes the rules predict actually 2 possible forms. And in other cases, they make clear predictions towards one form, but sometimes they one rule says, oh, this is a good plural, and the other rule says this is a good plural, and it's exactly the other plural for the same word. So there's a problem here. And what we were interested in is the duration, again, of our famous plural S. Does the duration of plural S depend on the proportion of plural versus singular? So that means, what's the structure of the paradigm? Is this a word that is plural dominant or singular dominant? And I illustrate this here with plurals, but the same story holds for S plurals. My Dutch is quite limited. So in boeken, this is a singular dominant word where you have a high frequency for the singular and a lower frequency for the plural. And there are words where the opposite is the case, and shoes in English too is such a case. They are called plural dominant words. And now another question would be, does the duration of plural S in variable plurals, like in pyramides and pyramide, depend on the proportion of S plurals? That is, again, a paradigmatic question. And we tested this by using corpora of spoken Dutch. And oops, something is wrong here. The first question we want to answer is, does the duration of plural S depend on the proportion of plural versus singular word forms? That's the dominance issue. And you can see here that for the invariable plural, S plurals, so words that only occur with an S plural, you see that the more these words have a preponderance of plural forms, that is, more plural forms being used by the speakers instead as against the singular forms, the longer the S becomes. So that means the stronger this representation becomes, we get enhancement. This is, in other words, another clear paradigmatic enhancement effect. Now, let's look at the variable plurals. This becomes more complicated. So the question is, does the duration of plural S in variable plurals depend on both the proportion of plurals and the proportion of S plurals? The proportion of plurals would be the plural dominant versus singular dominant. And then for the plurals, the proportion of the S plurals. How many S plurals do we get? How many plurals do we get? And as you might have already expected, things become messy and complicated here. So you see here on the x-axis the S bias. On the right, the words have a strong preponderance of having an S plural as against an plural. And on the y-axis, you see the S duration. And what you see is an interaction of plural dominance, which you see above the graph, and the S bias. So for plural dominant words, those are the one in orange, we see that the more S plurals we get among these many, many plurals, we get longer S durations. Again, this is paradigmatic enhancement. For the singular dominant words, we find the opposite effects. That's the green line. And now this may be a bit surprising, and it's not so clear what really the story is for those. One story would be that if you consider the singular dominant words and their S bias being low, it means that in general, we are talking about words that have fewer plural words. And among the few plural words, we have very few S's. And that means that they are highly segmentable. So maybe this is a segmentability effect, because recall, segmentability means the easily segmentable, the longer the thing should be. So that would be the story for the singular dominant words. but maybe it's also a case of syntagmatic reduction, in the sense that if you are at the other end, where you are in the plural dominant words, no, in the singular dominant words, so you have many singular forms, few plural forms, but if among the few plural forms you have many s's, then this may be a matter of syntagmatic reduction, a kind of informativity effect, because you know what's coming for these words, even though there are not so many plural words. So that's a bit of a puzzle and not very compelling, this what happens with the singular dominant words, but we still have to say that there are these paradigmatic effects. No matter how we want to explain or understand them, they are there. So let's do an interim summary here. We have seen 3 studies that show that co-activation of morphologically related forms in paradigms influences speech production. There's paradigmatic enhancement, where higher predictability of a form within its paradigm leads to longer duration, but we also see certain reduction effects. And the presence of such effects is unexplained in standard models of speech production. And also what is a bit puzzling, really, still to me at least, is the relation between the reduction effects and the enhancement effects. I mean, you can think up post hoc explanations, but it's not so clear where we would expect reduction effects and where we would expect those enhancement effects. So what we would like to do is move towards explanations. And I will consider a couple of studies using discriminative learning. This is a theory, an established learning theory that was recently extended to language. In this theory, learning results from exposure to informative relations among events in the environment. So this is partly error-driven. So co-occurrences of cues and outcomes are taken into account, but also non-co-occurrences where you would expect them. In the end, you get association weights in a network, and these association weights are then adjusted according to new informative experiences. And these association weights can be more or less conceptualized in the good old world of non-learning as contextual and paradigmatic predictability, if you like. But the general idea how linguists can use such networks is that we can use these association weights to predict language behavior, and this has been successfully done. And the one variant of this model that is implemented also as a computational model is linear discriminative learning. In this particular flavor of discriminative learning, you have a network which is a simple 2-layer network. It's linguistically transparent and interpretable, unlike deep learning networks in machine learning often. And the idea is to have a mental lexicon with 5 high-dimensional numeric matrices. So central ideas about how we process language are translated into numbers, if you like. So you get 5 different subsystems. You get a matrix. That's an object with many numbers representing the retina. You have an auditory matrix representing the cochlea. You have a semantic matrix, which represents the mental representations of meaning. And you have a form matrix, which represents how we speak. And you could also have it for written language by having a spelling matrix, which represents the typing. And we want to concentrate on form and meaning, that is the semantic matrix and the form matrix. And what you then do is you do a linear mapping. You map form onto meaning and meaning onto form. It's simple math. And by mapping forms onto meanings, you model comprehension. And by mapping meanings onto forms, you model production. Okay, very abstract, very hard to understand. How does it work? Assume that forms are represented by a matrix of triphones. So for example, here we have a triphone, the beginning of the word, then the sound k, then an a. This is phonetic transcription up there. And you can then represent the pronunciation for the word cat as a vector where you have a 1 whenever a triphone is part of the phonological representation of that word, and a 0 if it is not. This gives you then 3. This is, of course, a toy lexicon, a toy matrix. This gives you a matrix representation of the pronunciation. And it's called T because these are triphones to model the phonological transitions. And you can do the same for the semantics. So some of you might be familiar with distributional semantic models where you can represent meaning based on the co-occurrence of words in a text. And if you then either count or do other types of predictive measurements, you can get a row of numbers, a vector that represents the collocational properties of a word, which is equivalent to its meaning. So that's just a standard way of representing semantics as vectors. And you can then use transformation matrices, F and G as they are called, to predict meanings and forms. You can, if you want to do the semantics, you have to transform the form by multiplying it with the transformation matrix F. And if we don't know this, because we have only T and S, we need to take the inverse of S, multiply it by T, and we get our transformation matrix. And we can then use that transformation matrix to estimate all semantics by multiplying any matrix consisting of the triphones for any new words, whatever, to estimate their semantic vectors. And we can do a similar thing if we want to do it backwards. If we want to predict the form from the semantics, we just do the same thing. And this is then our production model. Now you might want to know, what do we really predict? We predict the forms and the meanings using these matrices. And if we want to predict a particular form of a particular word, we first have to predict the form matrix, as I said, and then you, when you look at it, you get the amount of support for individual triphones by the semantics of the word. So for example, this is taken from a paper where they modeled Latin words. And this is the form matrix where you then see the support that the individual triphones get from the words that you see on the left. And you see that VOC has very high numbers, but AS, for example, for VOCO doesn't have that. Now, how can you, this shows you the support for the individual triphones by the semantics of the word, but it doesn't give you the word form itself. For that, you need to link the highly supported triphones in the right order. And this can be done using graph theory. And this then yields something like this. This is not from the Latin data set because they didn't have a nice graph there. This is the word kicked, which was modeled in a different model. And you see that you start with the K here. There's a fully supported transition to key and from key to ik. And then you could also end the word, but this is not well supported. So you go to the next well supported diphone. Here it's diphones, not triphones. And this way you can establish the path that you need to travel in order to produce the word. Okay, now, how do we use this? We use the measures from the discriminative networks to predict duration. And We did this in 3 papers, first on the duration of final S, and then in a speech corpus, and then the duration of final S in English pseudo words. That was an experimental study. And finally, the duration of derived words in English using the BNC audio as a data source. First, final S. Here, the general facts are that depending on the function, you get different durations. So the clitic S is shortest. The suffix S, as in plural cats, is longer than the clitic, and the longest is the non-morphemic S. And this has been established in various studies. Now we want to model this. And the result was that increasing support for a morphological function from the network goes together with longer duration. And higher activation diversity for the different morphological functions, so this would be equivalent to lower paradigmatic predictability, leads to shorter S durations. So activation diversity would mean that for a given upcoming S, there are high associations to maybe 3 different functions, and not only to one of the 7 functions that we looked at. In the pseudo word experiment, we had basically the same facts, but we used a different approach. The Tomaszek et al. Was a naive discriminative learning network, and in Schmitz et al. We used the linear discriminative learning network. And here we found that higher semantic support for a particular phonological path leads to shorter duration. So if the semantics picks out straightforwardly a particular phonological path, then you articulate it faster. Higher semantic activation diversity, again, leads to shorter S durations. So if many different words are activated at the same time, this goes together with shorter S durations. Let's turn to the final study here, the duration of derived words and their constituents. What determines the duration of derived words and their constituents? There are inconclusive results for segmentability, informativity, and prosody. And here's the data set that we then use to study the linear discriminative network. We had 4,530 tokens with 363 types. And we had the prefix dis and the suffixes nus, lus, ation, and eyes. And as LDL predictors, we used 3 measurements, the mean word support, and we took this to represent articulatory certainty. And it is defined as the sum of the path support. So you add up all these probabilities that I showed you in this path graph, and you divide it by the number of path nodes, because if the word is longer, you want to see basically the mean support for this word from the semantics. And the second one is path entropies. This is basically the opposite. It's the Shannon entropy of the path supports. So if there's a high entropy among it, then you are cannot be so sure about these transitions. And oops, sorry. And the third one was the semantic vector length. So the mean correlate, oh no, that's wrong. That's not the mean correlation. The semantic vector length is the length of the semantic vectors predicted by the model, and the semantic, and we take it to be a measure of semantic activation diversity, because the longer a semantic vector, the more active is it on many dimensions, many meaning dimensions. And the dependent variable was the duration difference, that is the difference in duration between the expected duration and the observed duration. And the results are straightforward once you have understood them. We see an effect of mean word support. So the more the semantics support the articulatory path, the longer the duration of the word becomes. And we see the opposite happening for entropy. That's just the mirror image. The effect is not as strong, but it's the mirror image because entropy encodes insecurity, whereas mean word support encodes certainty about the pronunciation. So there's higher certainty. If there is higher certainty in the association of form and meaning, then we get longer durations. And if we look at the semantic relations between words and their properties, their semantic properties, we see that higher activation diversity is associated with shorter durations. So what's the bottom line here? Linguistic experience shapes degrees of activation, which then lead to structured variability in articulatory gestures and thus to different durations. And in this way, morphology can leak into what used to be called post-lexical phonology and into articulation. Okay, what do we learn here? There's overwhelming evidence that morphological structure influences articulation and thus the acoustic properties of words. And this fact needs to be accommodated in theoretical models. In general, we see that more associative support from the lexicon leads to longer durations. And in this idea of the lexicon, it's a network of related words within and across paradigms. Obviously, this makes life complicated, more complicated than the traditional structural linguist would have, but that's the way it is. And we also saw that linguistic experience shapes degrees of association and lexical activation, where linguistic experience is modeled as in linear discriminative learning. And this experience then results in variability in articulatory gestures, but this variability is structured and it's explainable as a result of the experience. So in this way, morphology can leak into what used to be called post-lexical phonology and articulation. The downside of this is that how exactly linguistic experience translates into the articulation is nevertheless still unclear, but so are many non-morphological effects on phonetic implementation. For example, word frequency. Nobody has a story of how exactly the higher frequency of a word would translate into a shorter duration of that word. Which processes would trigger that, in which way is unclear. So there's still a lot to learn here, but whatever we want to do in order to understand this translation into articulation, we need to take morphology into account. Thank you very much. That was it.
Okay, thank you very much, Ingo. For any questions, you can raise your hand. You can click on the reactions button and choose raise hand. Yes, Anne.
Thank you. That was really fascinating, filled with information. I'm still wrapping my brain around it. You know, one question I want to ask is about the focus on duration. You know, of course, duration is a very reliable measure, an unusually reliable measure. So I totally understand focusing on duration, but we also know that longer durations go with variation in articulate in the dimension that we can say is hyper to hypo articulation, which comes out in the spectral characteristics of especially vowels, but of course all sounds. And so I'm just wondering to what extent you have extended the window to look at spectral features as well as temporal features. Mm-hmm. And if that is another source of information about this interesting tension between informativity and morphological support, which sometimes seem to be in conflict, right?
Yeah, that's a very good question. Thank you. Of course, you are right. This is a very limited and narrow window that we look at if we concentrate on duration only. And you are also right in saying that it's not even clear whether certain durational effects are more articulatorily a kind of facilitation or of more effort. And I think this is a very complicated and interesting question. And in our group, I think it can only be answered by looking at articulation itself. And we have a few people in our group that have done this. One is actually here, that's Motoki Saito, and they have found interesting things going on there with exactly the kinds of trade-offs that you mentioned. On part of the acoustics, I mentioned the formants that Clara Cohen looked at, and we actually looked at the spectrum of the S's, center of gravity, and there is something going on there, but it's not, the effects are not very strong. Apparently, that's just there are too many sources of variation when it comes to these things. Yeah, but yes, you're right. There's a whole universe. Once you start finding these effects, you start thinking about, oh gosh, that there's a universe of effects that could be there and that you could investigate. Thank you.
Yeah, thanks.
Okay, thank you. Any more questions, please? Yes, Emmanuel.
Yeah, hello, Ingo.
Hi, Emmanuel. Long time no see.
Yeah, great talk. Thank you. Very fascinating experiments. I have two questions. The duration you're measuring is for how many speakers? And have you checked if there is a difference between, I don't know, old persons or young persons, or is there any different correlations that you can find?
Thank you. That's also an interesting question. So first of all, there is a lot of interspeaker variation. So these effects that we find of morphological structure on the acoustics is not present, not even present with all speakers. So we had to learn this the hard way when we wanted to come up with experimental stimuli, and we had people say the stimuli, and we had several people saying them, and some of these people, they showed the expected contrast that we needed for the experiment, but some speakers just didn't show it. And recently there's a paper in Journal of Phonetics where Patricia Strucharczuk and colleagues, they have investigated co-articulation, and they found this to be heavily speaker dependent. Some people show morphological effects and others don't. And I think one key to understanding this variation is that individual lexicons differ. I mean, that's not news to most people. Some people have larger vocabularies, some people have smaller ones, but this also means that their morphologies are not the same, because depending on how many and what words you know, you will have more access to morphological structure. And there are experiments that have shown this in reading experiments and all these things. But this is something that is well worth to investigate further, how these differences in lexical knowledge play out in this way. That's the first question. The second question concerns factors like age. In some of our studies, we have included age. If we had the information, we did include it, and usually the effects were straightforward. The older people get, the slower they become, the longer their durations become. This is not necessarily age decay, but it's rather a matter of the size of the lexicon. Our lexicons grow and grow and grow, and if it's not regular words, it's at least tons of new names that we learn almost by the day, and this slows us down.
Okay. Thank you.
Thank you, Manuel. Ignatius. Yes, Ignatius.
He's coming.
Hello. Please unmute your microphone, please.
Hello, can you hear me now?
Yes.
Yeah, thank you, Ingo, for a wonderful presentation. I'm sure you are wondering, seeing a Black person in the park. Well, I'm interested. I have read a number of your works, and when I got this invite, I was interested to be part of this. Now, I am wondering, I am from Africa, Nigeria, but currently studying at the University of Dar es Salaam in Tanzania. And I am wondering, for languages like African languages, where the demarcation between the phonetics and the phonology is blurred, and you have instances of co-articulations or clusters of consonants before vowels, and the movement from these consonants onto this vowel, sometimes the duration is hampered, maybe perhaps by the type of consonants and some other suprasegmental issues. How does this apply to issues such as that? Thank you.
Yeah, I think if I understand your questions correctly, you are asking how phonological and phonetic effects can be teased apart from these potentially morphological effects. And the way, and of course, this is a general problem for all of us. And I think the only thing we can do is try to either control for environments by setting up experiments in such a way that you control for it, or to include covariates that can then take care of the variation that comes in through these factors. But of course, you can only do this if you have some idea of what might be at issue. And that means you need to know the language quite well, or you need to be able to use electronic resources to investigate potential problems. And with many lesser described languages, this is of course a problem. I'm not sure whether this answered your question. What is, of course,
yes, it does. Yes, yeah. It does. I understand.
Yeah, but maybe another way to understand your question is to say that so far we have looked at an extremely narrow range of languages for these effects, and there are many interesting languages out there that have very complex phenomena in store that we could look at. And sometimes you see here and there some studies on some Indonesian language. There's a study by Seifert and colleagues on Indonesian, and there's one study of some Himalayan language by Kevin Tang and colleagues, and it seems that it's not only English and Dutch or German or Russian that show these morphophonetic effects, and it would be great to find people out there investigating lesser known languages for similar effects, because I think the phenomena are of course much richer often than those that we have looked at so far. I mean, we're investigating English S to its death, I sometimes think.
Okay, thank you. Any more questions? Okay, Antonis. Mr. Botinis?
Nene?
Ah.
Yes. Oh, thank you, Ingo. Your talk gave me many ideas. I would like to run to the lab and start experiments.
That's good.
Well, I agree. I totally agree with you. You are looking into duration, and I think duration is the basics of speech structure, because you have to have duration in order to do anything. Okay. And then duration contributes to all possible distinctions, not only to long or short vowels and so forth. It's wrong to look into duration the traditional way, like intrinsic duration. I think it's totally wrong. I mean, high vowels are much shorter than low vowels. In Greek, for instance, high front vowels almost disappear, just very faintly. And low vowels are really long. Well, maybe in long vowels, the jaw articulator is involved, which is somewhat slower, but I don't at all believe that it is physiologically determined. We do it in purpose. Okay, now, if we go down to several of your examples, you say here, freeze and freeze. What we have found in Greek, and it is in other languages as well, is that voiceless fricatives are much longer than voiced ones. So if freeze is longer, one aspect is the longer duration of the voiceless. But in that case, it's interesting to see what the rest is. Free from freeze and free from freeze. In Greek, we have also found that if you have a long or short fricative, it has an effect to the previous vowel. The longer the fricative, the shorter. It's a complementary thing. So it's several aspects we should be looking here. And now about the experiment. Here we are a society, and we can just set up an experiment in several languages. And I will refer to Greek. In Greek, we have like atonic, atrophy, and so forth, which is one syllable and one morpheme. On the other hand, we have many, forming only a syllable, not a morpheme. In accordance with your approach, if it is a morpheme, it should be longer.
Not necessarily. I wouldn't make any predictions, but and they could even be of the same duration, but I wouldn't be surprised to see differences in duration, systematic differences.
Because we have seen in several languages, if you have a syllable and you have one vowel and one consonant, and then you add consonants, the more you add, the shorter everything. The vowel and the consonants, shortening effect. I would assume that something like this happens in morphology, in morphemes. If a word consists of only one morpheme, it should be longer than if it consists of 2 or 3 morphemes.
Yes,
What would
of course.
you say?
I would say that this is totally true. Many things that you said are totally true, and many of these are we are able to control for. So, for example, with the voicing of the S, we controlled for that in different ways. We did it, for example, by either using the supposedly phonological specification, that is the unvoiced versus the voiced S, as it's listed in dictionary, so to speak. And we did it by using the number of voiced frames in the acoustics. And we then, you can play with these variables and do different types of transformations, and then use it as a covariate in your analyses. And you can then see even whether there's an interaction whether certain effects only play out for the voiced ones or only for the unvoiced ones. You can also encode the phonetic environment, whether there's a long vowel preceding or a short vowel preceding. And I think it's very important to try to take all these things into account, because otherwise you end up making conclusions that might be totally misguided because you have forgotten one of these covariates. And when I started this business, each time I gave a talk on our corpus analysis, there was at least one person suggesting 2 or more new covariates that I should include because they had found something in their language that might also influence. And I always said, yeah, thanks very much. I'll try it out. And sometimes it turned out to be an important additional factor, and sometimes it didn't. Yeah, but that's an empirical question.
Okay, thank you. Athena, is there anybody else who would like to ask? I have one more question.
No, you can continue.
Okay. What about morpheme versus syllable? Hypothetically, in a language, if you have this phrase, okay, both German and English, they are closed syllable, dominant closed syllable languages, or they permit both closed and open or whatever. So if the next word, phrase, something starts with the vowel, most probably this S will syllabify with the next, right?
Yes.
Probably, I say.
In some languages, maybe not so much in German, yeah, but in English, certainly.
Okay, if it syllabifies on the right, what is happening with each duration? Because then it will be the onset of the next syllable. And in the same language, if you have another word on the right, which the phonotactics do not permit, and it's syllabified on the left. So you have two different things. This morpheme may belong on the left as a coda, or on the right as an onset. What is going to happen then?
Yeah, again, I would say this is an empirical question, and I would try to see whether a pertinent variable that I would then introduce would make a difference. So I'm just checking the first study that we did of final S, and we included, I think, the following context into the analysis, and So we coded whether there was a pause following, a vowel following, a nasal following, a plosive, a fricative, or an affricate, and so on. And yes, there were some of these effects, but the strongest effect is the presence of a pause, because that leads to severe lengthening. But again, you're right, there are all these contextual effects, and one should try to control them as best as possible. We also controlled, for example, in that study, whether the word was mentioned previously in the discourse, because that also leads usually to shortening. If you've talked about a particular thing over and over, and then the next time you say it, you shorten it. So there are so many things going on, and it's yeah, and people always, you get those reviews where they always say, yeah, have you thought about this? And then you say, yes, we have. And then they still don't believe in the messy corpus data. And that's why experiments are extremely useful, because you can then show that it's not only a corpus effect, it is a real effect.
Yes,
but sometimes
I would say that your research, repeating your words, is extremely important, because what I've known today, it is that morphology per se has duration correlates. Up to now, and I'm doing this job for many decades, we were thinking about segments and syllables and stress groups and so forth. Today, I've learned that morphology and morphological units may have duration correlates. Thank you very, very much indeed. It was a great pleasure to have you with us today. Thank you, everybody. And
just a second, we have a comment from Katerina.
Yes, hi.
Hi, Katerina.
Sorry.
Thank you for an awesome presentation and a very interesting study. I think presentation format is not sufficient to understand it in all detail. So I've got a general question. So can you please elaborate more on what are the major implications of this study for linguistic theories in general? So what adjustments should be made in theories to address the phenomenon that you've discovered?
Wow, that's a very big question. I think what our studies show is that simplistic approaches to morphology and the interaction of morphology with the sound level are misguided, and that there is much more to discover and much more to understand. I mean, even the idea of these levels that we have, like the phonetics and the phonology, I mean, this has been questioned also on other grounds, but I think the research that we are doing also shows that something is perhaps going on which goes much beyond the complexities that current, especially generative models, try to understand. So that's my take on that, and I also think that we all need to be more inclined to take empirical evidence seriously. I mean, I still sometimes see studies where people just make claims, and they make claims about the morphological structure of words and about the existence of words, and then they make sweeping generalizations of how particular morphological constellations can mean particular things, and then I sometimes just go to a big corpus, and with a few clicks I can show 10 words that exist and are being used and against what people have written. So I think there's the larger implication is also that we need to take the data more seriously, and that we need to be inclined to test our hypotheses with data and with computational or statistical models. You would think that this is now standard, but I don't think so. I fear it's not.
Great answer. Thank you.
Okay, thank you all. Now Anton is, I think we're ready
Okay,
to end.
then to our next meeting after the holidays. I wish you good holidays. Don't work that much, and Merry Christmas to you all. And thank you for your presence today. And thank you, Ingo. Bye-bye.
Thank you very much for the invitation. It was my pleasure. Thank you very much. Bye-bye.
Bye-bye.